Welcome to the presentation of Project 2 Heredity.py of CS50 AI. In this project, we are going to find whether a person shows hearing impairment due to the gene GJB2. This is one of the leading causes of hearing impairment in newborns. Each person carries two versions of the gene, so there is a potential of passing that gene to the next generation. Here in the program, we check for the mother's gene, the father's gene, and also after performing probability algorithms, we conclude whether the child shows the trait or not shows the trait. According to specification, there are main three functions: joint probability function, neutralization function, and the update function. I am going to the program. In the program, the probes dictionary is in the dictionary in which we initialize the values according to the scientific data, like the probability of a person having two number of genes, one number of genes, 0 genes, then whether they show true or say they show the trait if they have 2 genes, 1 genes, 0 genes, etc. And also the mutation probability. This is how the people dictionary looks like in the project. This is the dictionary we will be iterating across, and the probabilities dictionary is actually the dictionary in which we initialize all the values. Going to the function, the joint probability function. In this function, we set the probability as 1. Then we use the for loop to iterate across each person in the people dictionary. Then I am using a number of genes function, which is a helper function which returns if the person has 1 gene, 2 gene, or 0 genes. Also, we are checking for the person's mother's, father's data also. So if the data does not contain mother and father, we will go with the default values. Also, we are also checking whether the person has shown true in the trait, if they show trait already. And then if there is mother and father, then we analyze their data. Then we put them in the probability inheritance function, which basically gives if the number of genes of the parent is 0, then the only way the person gets or the child inherits is due to mutation. If and else is 1 minus mutation, and the probability or say number of genes is equal to 1, then the probability is 50-50. The number of genes in parent is 2, then the only way the child does not inherit is 1 minus mutation, and it's the mutation. Then we return the probability after finding the cumulative probability or say the continuous probability. Then in the update function, we actually find the cumulative probability by adding all the probability distributions. Then we again calculate number of genes, whether the person saw trait or not. Then in the normalize function, we check whether all the probabilities sum to 1, and also we try to normalize all the results. So every probability, so if the probability is showing numbers in the 3-digit area, then we divide by 1000 or divide by the gene sum, hence making all the probability equal to 1, the sum of all the probability equal to 1. Then we return the probability and we get the answer like that. The dataset 1, which is family0.csv, contains data like this. Dataset 2 is much more elaborate with much more data. So let's go and run this program. The program runs with the system arguments, this argv, which for example in here we have to give the directory name / the dataset we want to run. So I am going to run with the first one, family0.csv, and we get the answer. I am going to enlarge the terminal window. Here we can see the Arthur containing, if there's 0, the probability of him having 0 genes is very high. He will not show a trait. Then James will show a trait because he will show 1 gene. So according to this program, he will have 1 gene and will show the truth. Then Lily will not show the trait. I'm going to run with the second dataset, family1.csv. and it gives much more people, so the data set is much more elaborate. So in this, only Fred will show the probability because he has more probability of having one gene, so he may show, or he will show the trait. According to the program, it's saying 100%, so probability 1 means it's 100%. So that's it for a presentation of heredity.py. Thank you.